We were deciding whether number 15 is linear, exponential, or neither, so we need to go through and find the slope and see if it stays constant the whole way through, and if not, then we'll decide whether it's exponential or neither. So if we look from -1 to 3, that's going up 4, and if you don't know, you can always do bottom minus top. 11, 3 to 11 is adding 8. Again, 11 take away 3 is the same as 8. 23 take away 11, this went up 12. If you go from -5 to 3, that's add 8. 3 to 19 went up 16. And 19 to 43, that was a little harder, so 43 minus 19, you can figure out that that's adding 24. So then from here, again, we want to decide, is this staying the same the whole way through? So we would do rise over run. So here it'd be 4 over 8, which 4 out of 8 pieces is the same as half. 8 out of 16. 8 is half of 16. And again, 12 out of 24. 12 is half of 24. And your calculator would simplify those for you too, but notice that it's 1/2 every single time. Therefore, it has to be linear. So number 15 is linear. Number 16 gives you a graph. And if you look at the graph, you'll see that that graph is not a straight line. Therefore, nobody should put linear on the test. If you do, I will minus off 4 points, not 2. Don't get that one wrong. If it's a curved line, notice that we have graphed many lines like this. Hopefully you remember that. This curve is exponential. And we have graphed curves just like that. You did a curve just like that on this last page right here. Number 12 was that same exact curve. And now we see it again. Number 17, you're going to distribute the 5 here because we want to find out what this simplifies to before we decide what it is, linear, exponential, or neither. So we got 3 plus 5x. 5 times 8 is just minus 40. And then we got minus 1. So if I combine all these like terms here, I can just type in 3 minus 40 minus 1. And you end up with fx or y, doesn't matter which one, equals 5x minus 38. So here, do you see this is y equals mx plus b form? And it does not have an exponent. It must be linear. So both of these, 15 and 17, are linear. Number 18, this y equals x to the third. You could make a table. Not that, don't use number 19 table. I'm using it because I can erase it. But if we plug in, let's say -1, 0, 1, 2, 3. If you plug in -3, that's -1 to the third power. You end up with -1. If you plug in 0 to the third, that's 0. Plug in 1 to the third, it's 1. 2 to the third is 2 times 2 times 2, which is 8. And 3 times 3 times 3 is 27. If you look at these numbers, there's no multiply or dividing happening there. This is a cubic function, and if you were to graph it, it would look like this. It's that weird curve. This is neither. Remember, you have to have an x as the exponent. Therefore, number 18 is neither. Next one, number 19. You want to be able to graph that equation. And so we're going to use -2, -1, 0, 1, 2, just like we did on that paper that we've done with this. So We know that the 0 number is 2. Hopefully you do. And so I can even graph that right away. And you know that it's times by 5. Times by 5. So 2 times 5 is 10. 10 times 5 is 50. If you go backwards, dividing by 5, 2 divided 5 is 0.4. And again, same thing is 0.08. If you don't know, plug the exponents in, replace the x. So plug the numbers in for x. So you'd have 2 times 5 to the negative 2, and just type it in your calculator and you can figure out these numbers here. So if you graph that, negative 2 up 0.8, it's teeny tiny. Over negative 1 up 0.4 is a little bit higher because it's close to a half. Over 1 up 10, so 2, 6, 8, 10. And then over up 50, it doesn't go that high, so we're just going to draw our curve. Well, it could have been a little better than that, but as long as we see where it's going. So we know that out to the side, it does not go negative. So here we know that the numbers are just going out to the side. It's getting closer to 0, and then up here it's getting higher and higher because it's multiplying by 5. The next one on your paper, we've got make a table. A tree frog population triples every month. Suppose that there are currently 10 frogs. If it's currently 10 frogs, then we know that it's 0, 10. Current, it's start. You can hold at most 21,870 frogs, and it's tripling. So 1 triples is 30. 2 triple is 90. 3 triple 90 is 270. So if I graph this, I can just graph 1, 2, 3. 0 is here. And if I graph, I need to get to 270. So maybe going by 50. So you got 50, 100, 200, 250, 300. And graphing it here. Make sure you go by the same amount every time. So here is 10. 30 is a little bit higher. 90 is just below 100. And then 270 is in between 50, 100, 150, 200, 250. Oh, it's above there. So we're way up here. And notice that this curves, which it should curve if it's tripling. And our equation, y equals our start number or 0 value is 10 times, it's timesing by 3 every time to the exponent x. That's our equation. And to figure out when are we going to have, we need to know when do we get 21,870 or more. So when do we equal that, or when do we get more than that? We can just keep going with the table, or we can actually just guess and check numbers in for x to see when do we just get more than 21,870 or equal to it. And it happens to be when x is 7. And in this case, 7 would represent the months. So it takes 7 months to give you that many frogs in your tree. Next one, circle the words that describe the table and explain why you circled them. So again, here we're going to find the change. And here it's going up 6, it went up 2, and then it goes up 8. It goes down 3, down 1, and then down 4. So we would like to know, is this staying consistent the whole time? So we got negative 3 over 6. That does equal negative a half. Negative 1 over 2, that is negative a half. And negative 4 over 8 does simplify to negative 1/2. So if it's staying the same, constant slope, it is linear. And because the slope is negative, then it is also decreasing. If you were to graph it, it'd be going down 1 over 2, down 1 over 2. It is linear. And the last one on here, which function is growing at a faster rate? Again, we need to think about which one is steeper or harder to climb. That's the one growing faster. So if you look at S, it kind of looks like S is growing faster at the beginning. So I might even say that. I'd say S is growing faster but then G, or what is that? R of X is, but R of X grows fastest over time. And the reason why is because Rx is exponential. Exponential functions will always beat out linear. Exponential functions will always beat out linear. Always. So even though you have a straight line growing faster at the beginning, exponential functions always end up being faster over time.